If we are having a question, suppose we are having the question like this. The largest number which divides 70 and 125, leaving remainder. I am discussing these questions keeping in mind that you already know how to find HCF, LCM, fundamental theorem of arithmetic. Do you know, Ritvika? Okay, you know. Ryan, you don't know, right?
No.
You said you know. Yes, Ryan?
No.
No. Okay, so I'm taking questions where we need to use the concept prime factorization, okay, even number, odd number, HCF, LCM. From here, I'm taking question for now. So leaving the remainder 5 and 8. Okay. Yes, at first, let me ask, do you know, Ritvika, how to do it?
Oh no, Mom, I don't think I'm aware.
Okay.
But I think we have to find the HCF.
Yeah. Okay. So let's continue. When I'm telling you, let's find. Okay. We will be solving this question, but before that, we'll be having the discussion of few basic concepts. So if I'm telling you, let's find the HCF of 2 and 16. Can you tell me what will be the HCF? Yes,
2.
both 2. Yes, Ritvika, 2. If I'm telling you what is the HCF of 12, 24, and 16, please tell me.
12.
Is it 12? Ryan, please check. 12 can't divide 16.
From 4. 2 square.
4, right? Yes, Ryan, take your time and check it. Is it 4?
Yes, no.
Okay, so HCF we have found for the first case 2. And the second case, we got the HCF as a 4. In the first scenario, are you able to see this HCF is such a number which can divide our first number completely, and the second number is also completely divisible by this HCF? Yes or no? Okay, HCF, if this HCF is dividing this first number completely, and the same HCF is dividing the second given number completely, right? Okay, similarly, in the next case, you have found the HCF as a 4. We can say this HCF 4 is dividing 12 completely. The same 4 is dividing 24 completely, and the same 4 is dividing 16 completely, right? Okay, so that means
Yes, ma'am.
once we are finding the HCF, we are getting such a number which can divide all these given numbers completely. Okay, if we understand that, then let's get back to the previous question. Now, one more example I must add over here, that if we are having, suppose we are dividing 17 by 2. Let's divide it to 8 times 16, right? To 8 times 16, right? And 1 is the remainder. Now this remainder, which is extra, okay, remainder which is extra, if I will subtract it from the dividend, this remainder which is extra, if I will subtract it from the dividend, can I say we got a number which is completely divisible by 2, right? Right? If I'll give you another
Yes, ma'am.
example, suppose you are having 141 and you are dividing by 7. Okay, let me check. Let me write it another number. 121. Okay, suppose you are dividing by 7. So first you will be doing 7, 1 times 7. Okay, 5 is the remainder over here. Now 1 you will copy. 7 times 49. 2 is the remainder. So that means we can say that in this dividend, 2 extra we are having. If we will subtract that 2, we will be getting what are we going to get? 119, right? Right? Please check
Yes,
if
ma'am.
19 is completely divisible by 7 or not.
Yes, ma'am.
It is, right? So when we are just excluding the remainder, okay, from a given number, we are getting such a number as a resultant, which is completely divisible by our divisor, right? Right? Now let's get back to our
Yes, ma'am.
question. Our question was the largest number which divides 70 and 125. The largest number which divides 70 and 125, if you will just find the HCF, okay, you will end up getting such a number which can divide 70 completely, and which can divide, that HCF can divide 125 completely. Yes or no? Okay, but we don't want to
Yes,
find
ma'am.
number which can divide this and this completely. Okay, read the question carefully. The question says that you have to find the largest number which divide this and this, but not completely. But not completely. It must have the remainder 5 from the first number and the remainder 8 from the second number. Are you getting it? Okay, so we don't need to find
Yes,
HCF
ma'am.
70 and 125. If we will try finding, okay, we will end up getting a number which can completely divide 70, and the same number can completely divide 125. But here we have to take the consideration of remainder. We want 5. Okay, we want, let me write it this way, we want, when we will divide 70 by a certain HCF or whatever, we need the remainder 5. Okay, and the same case we want to see over here when we will divide 125. This time when we will divide 125 by the same HCF, we need the remainder 5. Sorry, not 5. Let me check what was there. 8. Okay, 5 for the first number and 8 for the second number. Getting it, Rayan and Ritvika? Are you
Yes,
getting it?
ma'am.
Yes, ma'am.
Okay, here we are expecting 5 as a remainder. Here we want 8 as a remainder. But we understand HCF means a number which can divide this to completely. Remainder in that case will be 0. If we will just find the HCF of this and that, remainder will be 0. But I want remainder 5 from the first case, remainder 8 from the second case. Okay, so what we can do at first, from this 70 we can take out the remainder, that means 65. Okay, and the other number which is 125, from there we can take out the remainder 8, and we will be getting 117. Now these two remainders I am just keeping in my hand. Okay, the remainder 5, okay, which I have taken from the first number, that I am having in my hand, and the remainder 8 which I have taken from the second number, I have just taken out from the second number, that I am having in my hand. Now I can say that now we will be checking such largest number which can divide this 2 completely. That means HCF. Now if we will find the HCF of this 2, we will be getting a number which can divide 65 completely, which can divide 117 completely. And this remainder you are having in hand. In case again you are checking with the original number, automatically you will end up getting 5 as a remainder from the first case and 8 as a remainder from the second case. Is it making sense? Is it
Yes,
making?
ma'am.
Let's find the HCF first. Okay, HCF of 65 and 117. 65 means 13 into 5. Okay, or 5 into 13, whatever way you write. 117 means 3 into 3 into 13. How I am writing this factorization? Because I know the table of 13. Okay, 13 5 times 65 and 13 9 times 117. I know that. Okay, that's why I am writing this prime factorization this way quickly. Okay, now if we will find the HCF, we will check the common factor. And can we see the common factor is just 13, right?
Yes, ma'am.
Now this 13 is dividing our 65 completely. You can check it. Okay, remainder will be 0. And this 13 is dividing 117 completely. The remainder is 0. But the original number was 70. Okay, from there only we have taken out the remainder. And if you will check now, can you see you ended up getting 5 as a remainder from the first number? And 8 we were expecting from the second number, no? So let me write 125. Can you see? Are you getting it? So let me summarize it. Okay, what I'm talking about, if still you are not able to connect the dot, then I'm telling you that if you will find HCF directly, then you will end up getting a number which can divide 70 and 125 completely. If that number, okay, if such number doesn't exist, then you will be getting HCF as a 1. So far making sense? Okay. Now, since we need remainder in this case, and we have realized, okay, that when we will take out the remainder from a dividend, when we will take out the remainder, okay, then that number was completely divisible by 2, by 7, we were checking, right? So we realize we will be
Yes,
thinking
ma'am.
about HCF, that means completely divisible. Now let's take out the remainder and let's think about completely divisible case. Okay, because HCF means completely divisible. We cannot take HCF and remainder, both the scenario parallelly we cannot move. HCF and remainder, these two things cannot move parallelly. HCF means zero, remainder, zero. And if you want remainder, then first you need to take out the remainder. Okay, and you need to keep it in your hand. And then you can think about now whatever you are getting, 70 minus 5, 65. Okay, and the other number 117, these two numbers HCF, that means that number which can divide this one and this one completely. Making sense? Ryan, is it making sense?
Yes, ma'am.
Okay, always whenever you will encounter such question, if you are not able to recall these story, that means at first you need to take out the remainder, 70 minus 5 from the first number, 125 minus 8 from the second number. Whatever you are getting, that's HCF you will be finding. That's it. Okay, I'm giving you another question like this. Please continue. Just a moment. Just give me a moment, okay? Please check it.
Ma'am, 13.
Yes, Ritvika, what are you getting?
Ma'am, for the second question,
No, the first one.
ma'am, the first one I got 13.
Okay, you started doing second one?
Yes, ma'am.
Okay, if you can, please go ahead. Yes, Ryan, read it, and if you can, great. Try it. We'll be discussing it. I'm checking the answer for the first one. Yes, the first one's answer was correct, both of yours. Can we discuss it?
Yes.
Okay. Yes. Ritvika, are
Yes,
you
ma'am.
able?
Oh, yes, ma'am. I got the HCF as 30.
30. Okay. Let's see. So here ratio is given. Okay. Ratio between two numbers. Not only here, anywhere in mathematics, since this is in general you are having the class, okay, in from anywhere you are going to give any competitive exam, any exam, okay, these concepts will help you. So if you are dealing with any question where ratio is given, I am telling you ratio between your age to my age is suppose 1:3. So we cannot, like, from this ratio I can't say your age is 1 year and my age is 3 year. I can't say that, right? Okay, it will be completely incorrect because here comparison between your age and my age is there. Yeah, we can say my age is 3 times of your age, but okay, just the number which is reflecting in front of your age on the other side, we cannot declare that that is your age. So in mathematics what happens, no, whenever we are provided a ratio that is x is to y, is suppose 5:7, or maybe in another case p by q is 24/28. Okay, so for the first case x by y is given as 5/7. We don't know this rational number is reduced form or, okay, it is the original one, we don't know. Actually this was originally 5/6, or after doing the reduction of any number which was originally existed with, okay, after doing the reduction, let me reduce it first. 2 6 times 12, here you can clearly see after doing the reduction p by q became 6/7. Okay, so most of the time whenever a ratio is presented in front of you, always the below version is presented, which may or may not be the original one. Okay, that's why we cannot separate the ratio as it is. We can, for the first case, I cannot say, I'm not able to say that x is 5 and y is 7. If I will say so, blunder mistake I'm doing. Okay, for the second case, if I'm saying p is 6 and q is 7, blunder mistake we are doing, we cannot do so. So what we can do, we can say, that we can assume the first, we can say that x is 5k and y is 7k, we can assume in this manner. Or in the second case we can say p is 6k and q is 7k, we need to multiply the same variable with both of them. Why we are multiplying the same variable? Because in the other case, can you see clearly that it was originally 24? Can you see clearly it was originally 24 and I have reduced it? It was originally 24/28 and I have reduced it in a smallest fraction. That means same number I have deleted, I have cutted, I have cancelled out from here. Yes or no? Is it making sense,
Yes,
Ritvika?
ma'am.
Yes,
Right.
ma'am.
Okay, the same four which was sitting in the numerator and the 4 which was sitting in the denominator, while repeating, while doing the process of cancellation, we have just cancelled out that 4. Okay, so that's why whenever we will, from now onward, whenever we will just separate any ratio, the best way to deal with ratio, whenever, even if we are talking about age based question, okay, or any question, we will always be separate by taking the same variable. Okay, the way I have taken here 6k and 7k. And if you are thinking what if the original fraction, okay, here in xy case the original fraction is given as a 5/7, it is not the reduced form, originally it was 5/7. Okay, what if this type of scenario is there? Then also, even if we are writing 5k and 7k, doesn't matter. At last, okay, one more condition will be given which will help us come just creating a equation. Okay, and at last we will end up getting k value as a 1 if it was originally existed as a 5 by 7 only. Am I making sense to both of you?
Yes, ma'am.
Okay,
Yes.
originally it was 5 by 7, no cancellation, nothing has been happened over here in the left case. Then at the end, automatically you will see your k value will come out as a 1. Okay, after making a equation and solving it. For making a equation, one condition will be given always. Okay, so whenever we are just dealing with the ratio, we will be just doing always the same thing. So if you are having a triangle based question where I am saying the ratio between angles are, suppose 3 is to 6 is to 1. Okay, and find angles, each and every angles. Then this type of question you have done in the previous class. Here again I am going to tell you that let's repeat the same process. Ratio means we can say that one angle is 3k or 3x. Okay, another angle is 6x. Okay, or you can take k as well, and the last angle is 1x, that means just x. Okay, the third angle. And if we have to find the angles over here, then we will recall that in triangle angle sum property says that sum of all the three angle has to be 180-degree, right? Okay, so we will be adding all this 3x plus 6x plus x is equals to 180. And can you see we are able to find the value of x? 6 7 8 9 1 10. 10x is equals to 180. X value we are getting. Once we are having this x value, now we can say what is the first angle, what is the second, what is the third angle, right? So this example I have given only to you to understand whenever in any chapter, even if in real number chapter or maybe polynomial chapter or anywhere. Okay, have you learned polynomial, Ritvika?
Yes, ma'am, I've learned polynomials.
So you have learned polynomial. In case I will give you one example that the ratio between the roots alpha and beta is 2 is to 3, then we can assume. Okay, and I will give one more condition that uh, sum of the root is suppose 25, and find the polynomial. You don't know how to solve this question, but you know how to deal with ratio. Okay, you will be telling me that alpha can be taken as 2x or maybe 2k. Better to take 2k because we are going to frame a polynomial out of it. So 2k, and beta can be taken at 3k. Now the sum is given as a 25, so this two added together will be 25. That means 5k is 25. That means k is 25 by 5, that means 5. Now we know our first root is 2k. That means 2 into 5. That means 10, right? Ryan, is it making sense?
Yes, ma'am.
Are you understanding? No?
Yes, ma'am.
Okay. And beta will be 3k. That means 3 into
Yes,
5.
ma'am.
That means 15. Now we know the roots. Okay. Some of the root was already given. We could have proceeded for creating the polynomial, but product of the root was not known. Okay, and we needed to find alpha and beta to just take out that product of the root, and now we will be able to find the product of the root and hence the polynomial. Making sense?
Yes, ma'am.
Let's get back to our question. If two numbers are in ratio 2 is to 3, their LCM is 180, then their HCF. Okay, we can assume the first number or one of the number. Okay, one of the number is 2x or 2k, another number is 3k. Now you understand that when you are having such terms, then how to find the HCF and how to find the LCM, you have learned that. Okay, so 2k means 2 into k, 3k means 3 into k. If I will ask you what is the LCM, what will be the LCM?
No, 180.
Yeah, what you said?
180.
180. But out of this number, if we will look at this number 2k and 3k, what we are going to say as a LCM? By using the logic prime factorization, taking out the common, and then taking the extras and all.
6K. 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 6K
6k, is it making sense, Ritvika? That is
Yes.
180. Okay, we are getting k as a 30, which you have already found. Yeah. Okay, so k as a 30. Now we can find the first number. We can find the second number, but why we will do so? Okay, are you able to understand by looking at your number that here HCF is just k? Making sense?
Yes, ma'am.
Okay, because common is just k. We cannot break this to more. Okay, and 3 also, we cannot break it more. Got it? Okay, let's move. Just a moment. Please do this one now. The decimal expansion of rational number 14587 over 1250 will terminate after
And two decimal place.
okay. Yes, Ritvika, please check it. Is it 2?
I think it's 3.
3 you are getting? Okay, let me check it. 125014587. We know 12 2 times 24, so still one time we'll be having, right? Yeah, 5.
Yes, ma'am.
Again, we'll be checking in this manner. 12 5 times 60, 12 6 times 72, 12 7 times 84. So 7 times I will not check. Okay, 6 times I'll check. Okay, 5 times I think it will go. Yeah, 5 times, right? Right? Right, Ryan? Or maybe Ritvika. With anyone, any of you, is it matching? Or both of you are able to relate with it?
We can take.
Are you getting the same? Have you got the same?
Mom, we can take 6 times, right?
1250 into 6 is equal to 750.
Okay. That's why I was telling you. Please tell me what you are getting. 6 5 times 30, 0 carry 3, 6 2 times 12, 13 14 15, 5 carry 1, 6 1 10. Oh yeah, 7 5 0 0 we are getting. Okay. So yes. Why I have taken 5 times? Wait. I think I have deleted one more step. No worries, I am writing it. Thirteen minus 5, 3, 8. 8700. Okay. So will it go? I think it will again go 6 times only, right? Okay. Because 7 times, if we will take 7 5 times 35, 5 carry 3, 7 2 times 14, 15 16 17 17 carry 7 carry 1, 8 7 5 0. So we will be getting again 6 times, right?
Yes.
So we are getting 0 0 2 7 8 minus 7 1. 1 2 0 0 we are getting one more 0, and I believe 9 times it will go, right?
Yes, ma'am.
Yeah, 9 times it is going 11250. Wait 11250. Yeah, 750 we are getting, right? Right, Ritvika or maybe Ryan.
Yes, ma'am.
Okay,
Yes,
now
ma'am.
able to get 10, but still, okay, let me check. Yeah, 7500 we ended up getting. So we were getting 7500 6 times, right? Right?
Yes, ma'am.
Yes, ma'am.
1 2 3 4 decimal places. Is it so? Let me zoom it. Please check it, the steps. I'm just confirming by calculator also. Check it. Yeah, 1 2 3 4. 4 decimal places. Option D is correct option, right? Right? After decimal, 4 digit. 1 2 3 4. So 4 decimal places. After that, it is getting stopped. Stopped means it was getting terminated, right?
Yes, ma'am.
Okay. So yeah, option D is correct option. Next. Suppose we are having a is x cube, y square, z to the power 5, and b is x y cube z. Please tell me what will be the HCF of these two.
X y square z.
Is it so, Ritvika?
Oh, yes, ma'am. X, Y square, Z.
Yeah. Okay, it is the least power x y square and the least power z. Suppose I would have written k over here, then what will be the HCF?
X, Y square, Z.
Still, yeah. And LCM will be with that k.
X cube, comma y cube, comma z cube, comma k.
Z to the power 5.
K.
Yeah. Right, Ritvika?
Oh, yes, ma'am.
Okay, like this will be finding. So, just a moment.